usually say thanks everybody for coming out, but you're there, I'm here. But happy to at least be with you all virtually. So today, not a big surprise, we're talking about Phoenix Live View, which has been a big focus of mine and the Phoenix team for the last couple of years. But I think we're really at an inflection point with Live View and the features that we're delivering in the next release that is going to take it from, like, we've been building all these building blocks that have been really powerful and valuable to folks, but we've been doing all the work putting the building blocks together to kind of enable some really, really neat features. And we're kind of at this inflection point where we can start delivering on some like really powerful features on top of these building blocks. So we're going to talk about that today and how I really see this model as the future of full stack development. We're seeing this catch on like wildfire across really the entire ecosystem. Name a language or framework they've likely adopted or tried to adopt some kind of inspiration from LiveView. But the reason I can't be there today, if you missed some personal news in my life, I have a 6-month-old at home named Callan. So I wish I could be there. Really looking forward to being on site, see all my Elixir friends next year. But for now, I am virtual. So here's Callan here, you and I hanging out, being matchy-matchy. But if you've also been following me, there's also some other big personal news and some news for Phoenix is I've joined a company named Flyio. And Flyio is a platform that hosts your web applications. You can kind of think of it as like Heroku, but much better. So the whole idea is, you don't have to worry about ops, and you can easily deploy and provision applications. But what Fly does is you can deploy these things geographically, and it will connect them together automatically. So it's kind of like taking the idea of a CDN where a CDN will take your JavaScript and CSS assets and place them around the world close to users. But with Fly, you can just deploy apps and databases around the world close to users. So they really went off 4 years ago and built this perfect platform for Elixir and Phoenix and LiveView. And we found each other earlier this year and realized that they kind of made the perfect platform for what we're trying to accomplish. So the neat thing about Fly is, again, there's this geographic deploys, but then you can cluster your applications together, and this happens, cross data center, but over WireGuard using network details. But basically, it allows you to cluster Erlang geographically in a secure way, and you don't have to worry about it. So I'm super excited to see what we can do on Fly, especially with Elixir and LiveView, because imagine asking any company or team, like, hey, we need to deploy an application globally around the world. We want to be fast, close to users, but data should be replicated and servers should talk to each other. Going multi-region, even within AWS, even within the US, is takes an army of engineers. So I think we're going to see folks accomplishing things that are prohibitively expensive or impossible on other platforms, just because we have things built in to the platform to do distribution. So definitely check Fly out if you want to deploy Elixir or Phoenix. It's awesome, and I couldn't be more excited about joining the team. But since this is a weird couple years for me with the pandemic, I haven't given a talk on Phoenix 1.6 or LiveView 0.16, which have been out for maybe 2 or 3 months now, or a couple months now. So if you haven't followed along, I want to just cover some of the big features that landed, because I think, other than a blog post, we didn't really get to show these things off. So Phoenix 1.6 includes the Phoenix Gen auth generator, which is like authentication that we generate into your application. So out of the box, you get like user login, registration, password resets, like everything that you would expect. It's been security audited and tested. So we generate that into your app, and the only dependency that is required is like the password hashing library. So it's something that you can take from a solid base that's tested and grow with, and not be kind of beholden to a library author to hopefully support the kind of use case that you have. And then along with that, we added a mailer that you can generate with Phoenix Gen Notifier, because for a long time we punted on mail because Hex has libraries to do emails. And we've said, like, well, you can just use a library. But the problem is like making people roll that themselves, especially for a framework that we want to include like the 80% use case for everyone. Like if you have users logging in and registering, you've got to send emails. So we included a Gen Notifier task that allows you to basically bootstrap that process. And the neat thing is it includes development mailbox previews. So we have a route in development in your router that allows you to go to like /mailbox and see the emails that are being sent in the app during development. So nice quality of life things. And then a big thing that has resonated with folks is we dropped Webpack and Node and NPM entirely from the asset equation. We're using this portable Go binary, so you can bundle your CSS and JavaScript without Node even being on the system, which I've talked about before on podcast. You can hear our rationale on that. But basically, the goal is you should be able to start an app or inherit an application 5 years from now and just start editing it and editing your CSS and JavaScript and not having to spend 3 days trying to figure out how to get Node and Webpack to work. So definitely give that a shot if you haven't yet. And then on the LiveView side, we released 0.16 right around the same time. That included some major features. Live session was one of them. Phx was really the biggest feature, which is an HTML-aware template engine. And we'll go into what that does for us. And then along with Phx, we added function components that allow you to write basically HTML tag-based components in LiveView. And we'll see kind of what those look like in a moment. But we'll start with live session, because I think live session is one of those things that like you may see it and you're like, oh, it's kind of cool, but it's really, I feel like a major advantage that we have that most other platforms can't do. And what live session gives us in LiveView is the ability to, in your router, say routes are grouped underneath a named session. So by default, if I have like these posts that are publicly viewable, all live routes by default are under like a default live session. And then if I have admin-based routes, they have different route layouts, they have different authentication mechanisms. I can put those underneath a different live session. And the neat thing about this is that means we do all page navigation through your live redirect on the client. We do all of that over WebSockets. So instead of like a single page app that does push data on the client, then does an AJAX request or a bunch of HTTP requests to get data, we're doing a single WebSocket frame to essentially do page navigation. So we'll do a push data on the client. We'll do a single WebSocket frame that says, hey, mount a new live view for me. And then it just mounts and the page updates. So we don't have to like reestablish an HTTP connection and go through all the HTTP overhead of like parsing headers, doing token verification. So it's extremely fast page navigation over a WebSocket connection. And the critical thing about live session is LiveView, the LiveView model is the HTTP quote unquote dead render, and the live render where you connect over WebSockets is a shared code path. So the plug pipeline has very little to say as far as LiveView is concerned, because it has to work over HTTP and it has to work over the underlying channel transport, which is usually WebSockets. So there can't be like, oh, well, just call my authentication plug for the admin routes, because when you connect over WebSockets, there is no HTTP plug to run. So live session, the ability to do navigation over WebSockets means we need to have some shared grouping of routes that say these routes have the same life cycle. They should have a different layout. They should have different authentication mechanisms and code paths that run for them. So that's what live session gives us. But essentially what you can get is you add a live session to your routes, and then you continue to use live redirect in your router. And out of the box, now you have at least twice as fast page navigation, because we're not doing 2 round trips anymore. And it's going to be super fast because it's over a WebSocket frame. And don't take my word for it. We're seeing some pretty awesome anecdotes. This one's via Twitter. So Alex upgraded an 8-month-old LiveView app, and he said he was blown away that he said it responds faster than any single page app he's ever built in the past. So I think people hear this kind of idea of LiveView and they think it's heavy. I think LiveView navigation is probably similar to like PJAX, where you do an AJAX request and then you just do like an inner HTML replace. But again, we send a single WebSocket frame over the established connection and patch the DOM, and it's going to probably blow you away. So definitely check it out. But then alongside live session, I had this idea. I mentioned that plugs can't really get into the equation, or have never been able to in LiveView. But especially being able to do the live redirect over WebSockets, we had to have some kind of hook to allow you to get in the lifecycle process to run code for authenticating and wiring up LiveView information. But at the same time, people were having problems saying like, well, since I don't have anything like plug in LiveView, I have to write like all these shared utility functions, and then every mount in my LiveView, I have to run the same function over and over to like assign the current user or do authentication. So it was kind of a kludgy experience to enforce shared code in all live views, let's say, that want a current user to be there, because you had to constantly like call these utility functions. If you forget, you have an error. And it made things hard to extend because libraries couldn't say like, okay, this component expects pub sub messages to be subscribed to, and then they're going to update inside the component, be rendered. But then every live view that wanted to use a component had to add like a handle info clause. So things were not very extensible. And this is where Lifecycle Hooks come in that Michael Crum on the Phx team implemented that solve really a number of problems. So what that looks like is at the live session level, you can almost use Lifecycle Hooks as a router pipeline would. So I can say for any route in this live session, so all my admin routes should have like an admin live auth hook that enforces authentication as an admin. And then you don't have to go into every live route under the admin section of your app and like constantly say, authenticate the admin, authenticate the admin. You can just do it in one place and all the routes have this enforced. And what that looks like for a module is you implement a callback named onMount. And here's where you can hook into the mount lifecycle. So the whole idea of lifecycle hooks is you can either continue or halt the lifecycle continuing. So if I want to intercept a mount event, I can say, okay, like the user is authenticated, I'm going to assign the current admin, and then continue means, okay, continue calling down to the live view code that I'm living on top of. Otherwise, I can halt and redirect. So not a whole lot going on here, but this is going to apply to everything that you put underneath the admin live session. But it goes further than that and then at the live view level, I can use the onMount macro to specify, live view specific things. So here, if I wanted to authenticate directly in the live view itself as an admin, I can specify that. Or I can just say, if I have some notification feature in my app, like imagine this scenario where you have in your live layout notifications that should show up for a user. That's going to show up in the navigation bar. So you need to be able to get assigns into every live view from the router that's rendered in the live layout somehow. And then you also need to say, like, I'm going to be broadcasting pub sub events that need to be intercepted in a handle info. So there was no real great way to do this prior to Lifecycle Hooks. You could like do a bunch of code injection. So every live view basically in your router then would have to have like handle info clauses injected, and it became a big problem. But now with Lifecycle Hooks, you can say I have a notification hook that onMount is going to wire up everything that should be required to handle notifications in the layout. And what that would look like is something like this, where I can use onMount, I can say I'm going to attach a hook to other lifecycle events for this live view. And you can attach hooks for basically all the lifecycle events: handle info, handle events, mounts, and handle params. And this allows you to get on the action on any level of the lifecycle, and then either continue or halt based on what you see. So in the case of notifications that I want to put in the live layout for everyone, I can say I'm going to assign some empty notifications. So now anyone that uses this lifecycle hook in their live layout can just start rendering notifications. And then I can hook into handle info for all these live views via attach hook. I'm going to name it subscription because we allow you at runtime to attach and detach. So thanks, Michael Crum. He came up with this idea and API instead of making it all compile time, and it's awesome. And the cool thing here is then I can say this info function should be invoked before we call your live view handle info. And then the job of this is to do whatever it wants. And then critically, it either halts or continues. So we can say if I'm looking for a specific shape of data, like a tag tuple of notification, I can say like, oh, that's what I'm looking for. And I can update the notification assign. Otherwise, I define a catch-all clause and just say continue on and let the live view handle info be invoked, doing whatever it's going to do with other messages that it cares about or other hooks care about. So all these hooks compose, you can have multiple of them, and they can get in on handle events, handle infos, and this is going to make live view applications way more extensible. So you can have reusable components, and this solves a number of like authentication concerns and extensibility concerns in one abstraction. So super nice, awesome work, Michael. And CogniSense, where he works, has allowed him to spend open source time directly on solving this problem. So a big shout out to them as well. So perhaps the biggest new feature in the last release was Heeks. We pronounce it Heeks. People have asked online, how is this pronounced? Because like EEX was pronounced EEX, not Heeks. But Heeks is, I think HEEX is a bit too burdensome. So Heeks stands for HTML Aware EEX. It's our HTML Aware template engine. It replaces the live EEX or Leaks template engine, which was not HTML aware, but did diff tracking. So Heeks is like, does diff tracking and it's HTML aware. And I've got to give a big thanks to Marlis, because he basically extracted this from the Surface library and contributed it back to LiveView. It's a huge amount of work. So he's done some incredible work on the Surface library. And if you're not familiar with Surface, it's a library that builds on top of Phoenix LiveView, and it added a HTML aware template engine. It added compile time checks for assigns. He added like the Surface catalog for automatic generated documentation. So there's really a bunch of great features in Surface that he's kind of blazed the trail on, and he was kind enough to contribute this back into LiveView based on some of the great work that he's done. So huge shout out to Marlis for helping us with this. But what Heeks gives us is, like I said, HTML parsing and validation for EEX. So that means if you have a div tag and you leave off a closing tag, it's going to raise a compile time and tell you. So if you've been in the case, like I have many times, where you're taking a design and you're copying and pasting and cutting it up into components or templates, if you leave off a div tag and you're chasing down your failed HTML validation that you're running through, right? The browser kind of tries to deal with it, but it's incredibly hard to track down when you mess up. And Heeks is just going to give you that out of the box by validating the HTML at compile time. And the other big thing that it gives us is a new syntax for Elixir expressions within an HTML tag, and we'll see what that looks like and talk about that in a moment. And then it also gives us a tag-based syntax for rendering function components, which is a huge quality of life and composability improvement over trying to like litter your markup with a bunch of Elixir functions, and you kind of lose sight of what your markup structure was intending to do. But if we look at EEX, it wasn't terrible to write Elixir inside an HTML tag, but it was fine, right? But it wasn't great. The EEX expressions, they have the same opening and closing, less than or greater than characters as an HTML tag. So one, it's hard if we tried to validate your HTML with the same syntax, it's very difficult. It's doable, but very difficult to figure out what's an HTML tag and what's not. But also, EEX allowed folks to basically, in the middle of a tag, just inject a string that gets shoved into the HTML tag. So there was necessarily a restriction we had to add, because EEX allowed you to build arbitrary HTML that the parser literally couldn't see. And it was kind of kludgy. It was very verbose to do all of the EEX characters within an attribute. So what HEX or Heeks does is allows you to do like a React style bracket syntax that runs your Elixir expression for HTML attributes. So it's a very succinct syntax just for inside HTML tags, and your regular EEX rules apply if you're writing outside of an HTML tag. So it's a syntactic feature for HTML attributes with some other nice features. One of which is if you add like a required attribute and you give it an assign like required, if that is falsy, it will automatically remove the attribute name. So a lot of folks have been in EEX where if in EEX you specified required and then greater than EEX and you said an assign there, if that was false, it would still have the tag name injected. So in this case, we do that automatically for you based on truth or falsiness. And then you could also use a spread syntax, which is the last thing in the tag is just a bracket and a map of attributes. We will automatically spread those in and add them to the element. So super nice feature that, again, you didn't have with EEX. And along with new features is this idea of being able to inject assigns into a function component, which we'll talk about. So we have this new let syntax, which is the ability for you to pass data from a component into the inner block. So in this case, we have a form, and we have this standard text input and label functions that want to receive that form. So now the component itself will say, here is the assigns for you. Before we had this idea where form for return the F variable, and then you had to use that internally, but then that broke change tracking. So now we've solved that with let bindings that allow you to give assigns to an inner block for a component. And then again, like Phoenix Target myself, it's just way quality of life improvement without all this verbosity of EX for HTML attributes. And it composes super nicely with the HTML you're writing. And that brings us to function components. And function components replace stateless live components, which have been kind of problematic in that people are creating way too many live components, and you can only create one live component per module. So they're creating a bunch of modules. They don't compose well inside HTML. And really, these components should be much more granular. So function components both solve a big need that we had as a deficiency in live components and stateless live components, and also are just a better abstraction for kind of componentizing pieces of your markup. So one great example is like a modal. So here's a Twitter Bootstrap modal that we have. And instead of copying and pasting this around the app, right, you have like a bunch of classes. You have the tab index that if you forget, you're going to fail your accessibility. And there's a bunch of concerns here that it would be nice to compartmentalize this, right, and allow the caller to say, I just want to render a modal. I don't want to know about the details. So function components are great for this, because if you try to do this prior with live components, one, you would want to use a stateless live component, because the server shouldn't have to keep track of any state just to show a modal, right? So people were using state on the server just to compartmentalize markup, which is not what we want. And also, you lost the intent of what the template wanted it to do. So you would write something like this, where you say, I have a live component named modal. I'm going to pass in the title, and then there's like a cancel and confirm button that always show up on a modal, right? So I can allow the caller to say, hey, just pass those in as assigns. And it works, it's fine. And then there's a do in block that is the inner block. So this is doable, but it hides the intent of the fact that this is a modal, but it's fine, right? But it gets complicated the more you try to kind of take this idea, because you probably notice that, like, okay, well, my cancel and confirm buttons are not just for a modal. They're likely going to be for any form in the application, any dialogues I want to show, any screens I want to show. They probably have accessibility concerns based on their call to action being cancel and confirm. So let's say I would like to kind of componentize that in my app. So to do that, you might say, like, well, I can not pass those as assigns, and I can just inject something and say, okay, this modal footer container is going to have these helper functions like cancel and confirm that take a label, and it's going to work for me, right? My function can return a little bit of a template, and that'll work. But then, like, you go down this rabbit hole, and you're like, well, if I want my buttons to also support like font awesome icons, if the caller wants, then I need to add like a do in block. And I could make this work, but if you've read the our LiveView documentation, you would know that passing do in blocks to functions basically breaks change tracking, or the app would work, but we would send a lot more data than necessary, because do in Elixir is a keyword list. So we would always have to evaluate and execute this do in block to call this function. So you would not get the benefits of change tracking, and it breaks down quickly. And we also lose sight of kind of the intent of what this code was attempting to do, which is just render a couple buttons. And then worse than that, if you read the documentation and you're like, well, in order to get necessary change tracking and enter content do in blocks, I can just make everything a live component, right? And then you end up with a case like, you wouldn't want to do this, please never do this. But this is kind of what we were seeing, is people were making all of these live components, like a cancel and a confirm live component, and all it did was render like a couple lines of HTML. So a module per a couple lines of HTML was not what we wanted to see. And then if you read this code, you have to like parse it line by line to say, oh, it's like a modal. Oh, there's a cancel button here. You lose the entire intent of the markup. So we came in with function components, and what this allows you to do is gives you a function invocation syntax as an HTML tag. So here, .modal means there's a modal function in the scope of this template that I can invoke and then specify as an HTML tag, like .modal, and then the closing tag /.modal. And then everything within that is the inner block of the component. So like your do-in block in Elixir. So it's a syntactic feature that allows you to compose HTML by calling these functions that build HTML for you. And the nice thing about this is you can declaratively, write these things within HTML. I know intuitively, I look at this, I'm like, okay, there's a modal, and then within that, I have my regular div markups, and then a cancel and a confirm component. And then inside that, I can have the open tag and then a font awesome icon, and it all composes very nicely. So this is the big idea behind function components. And the neat thing is they're super simple, and they can also be based off of a actual module name or alias. So if I wanted to, if you're not a fan of .modal importing everything, you can call it off a module, which is like UI.modal, and this is just a function invocation, right? So you can also alias a module and call it in the same way. And what this looks like is just a simple function. All function components take assigns, and they return a sigil H Heeks template. So in this case, here's the Bootstrap modal we saw. I'm throwing the assign in there, and then my render block takes whatever the user passed between their HTML tag, and that's the inner block. That's just the do-in block. So now I have nice compartmentalized markup, and I'm not making one function per module. I can say everything, all the core UI components can live in one place, and it's super composable. But you may have noticed there's some deficiency here in the modal example, in that I had to create, I had to wrap the buttons in a modal footer class. So, it's fine, but I'm kind of leaking the markup class details that may change, and I'll have to go find everywhere that I had that and change those. But then also, it actually doesn't work really well in this example because the modal footer is supposed to be outside of the modal body container, but we had to put it inside. So you have this case where there are certain times where you want the caller to be able to say, I want to put this content in the component, and it's not just a string, it's like HTML, arbitrary HTML. So we can see that with, imagine you wanted to say for the modal title as a caller, instead of saying it's a string, I wanted to pass like my own H2 tag with its own classes. You could try to like force HTML into the attribute. This wouldn't work. Well, this could be made to work. Please never do this. But before, people had no option to say, well, I want the title assigned to be arbitrary HTML. And, this would be HTML escaped and wouldn't work how you would expect, but like there was no way to say like, well, show HTML for me instead of a string. So this is where slots come in that allow you to specify for this area of the component, and the component knows how to render it. I want to put this content. So we can end up with something like this, where we have a function component named modal, and we have the syntax where you can say :header, and within that, that's a named slot named header, and I can tell as the caller, like, hey, component modal, here's what you should put in the header for me, and this can be arbitrary HTML, whatever I want, and then anything not in a slot is just going to be the inner block as before. So I can say, like, for this header content, please put this here. Here's my modal content. It can be arbitrary HTML, whatever I want. And then, hey, you have a footer slot that should be wherever the modal footer should be internally, and I want to render my own components there, like a cancel and a confirm button. So it's a declarative way in your template to instruct the component. We want to put data or slot data in to this space, and we don't care about the details. You are the one that knows about the details. And internally, it's super simple the way that works. So if we go back to our modal, we used to have render block, and that's being replaced with render slot. And render slot is going to take an assign, like header or footer, or inner block, which is the default slot. And the component can say, well, in the modal class, or in the class modal header container, put the header slot. In the modal footer, render the footer slot. So it's just a declarative way with a new syntax with that colon prefix to name areas or name assigns in the component that are arbitrary HTML that can render their own components, do whatever they need. It's really an essential feature if we're working towards a goal of the ecosystem having reusable components off the shelf. So if someone wanted to put a library together with modals, buttons, if they wanted to wrap Tailwind or Bootstrap, slots are essential to make that happen, because otherwise you can't accomplish these goals just using arbitrary, string assigns. It falls down quickly. So slots are on the master branch and will be out in 0.17. And I really, it's this turning point for us to have the community start releasing, I think, really extensible and usable UI libraries on top of LiveView. So I'm super excited to see that this landed. Again, huge shout out to Marlis, who did the majority of this work along with Jose, getting slots in place. Can't wait to see what we're able to actually build with these now that we have this in place. For me personally, I want to see what we can do with Tailwind, but again, you can take this with Bootstrap, any UI library, or your own custom CSS, and start componentizing your markup, and not worrying about, as a caller, how do you create a modal with all the class shenanigans. But slots go even further than that, because slots are really a list internally. So you can implement like a table by specifying the same name slot multiple times. So in this case, I can say, I have a table, I can pass it all the rows as a collection. And then I say, well, I want to specify arbitrary amount of columns. And then internally, the component can then pass you your user as it internally goes through each row. It passes you back through let. You can get back access to your user. You can define all of the columns in line here without having to do all the TRs and TDs, and the slot is just list aware. So you can do some really, really neat things with slots. And again, this was an essential feature for, I think, generalized component libraries on top of LiveView. So watch this space. I think we're going to rewrite our live generators to take advantage of all these things. So we're going to do some experimenting internally on what makes sense out of the box to generalize, because I think folks can absolutely, in 12 lines of code, write their own table component. But I think out of the box, you'll see us kind of come up with some primitives. Like, we generate a live modal function today. That's going to be replaced by a modal component. We'll likely generate a table component. So definitely keep an eye on this and reach out to us if you want to get involved in converting some other CSS libraries, maybe with some off-the-shelf components. And another huge feature which we've been working on, that it's in a PR, not yet merged, but basically baked at this point, is JS commands. And this is something that has been long in the works as far as on our mind on the Phoenix team, because we often end up in cases where we want to do some simple operations on the client that shouldn't require a trip to the server, but then you have this nuance where the DOM is being patched and undoing JavaScript that's happening on the client. So there were a lot of cases where people would write JavaScript hooks that just change the DOM a little bit, and then they would have to like ignore the whole container, and it didn't compose nicely with updates arriving from the server. So we've solved that with what we're calling JS commands. And where this started was we had the modal that we generated for the Gen Live task. That we put this in everyone's project. So if you've ever run phoenixgen.live CRUD generators, you'll end up with a modal component in your project. And anyone that's run that previously will know that this is a stateful component. And the only reason it's a stateful component is it has to handle the close event. Because when we say capture click or hit the escape key, we send the close event to the server. And all that close event does is push fetch back and tells the client, go back, or go where they came from. And this was super not optimal, because if you'll notice, right below the capture click and window key down, we render a live patch close button, which goes back to wherever they came from. So the UI already literally has a link on it that returns to where it came from if the user clicks it. So we were going all the way to the server and back to do something that the client already knew how to do. But because we didn't have this idea of like, well, how do I get the Phoenix click or the Phoenix window key down to click the live patch instead of sending an event to the server? And this is where libraries like Alpine come in, where a lot of users would throw Alpine in, which allows you to annotate your markup with JavaScript. And then you can say like, well, dispatch this event, add or remove a class. So Alpine is really great for that. But Alpine gives you really full reign of running JavaScript in your HTML bindings. So for us, one, we didn't want to ask a user to learn another library. And for us, like all we needed to do was click a link or toggle some content. So for us, Phoenix JS commands are really about declaratively executing utility functions on the client that should happen on the client. And they're super easy to use. We're not asking users to learn anything new. And then also we're already running all this code and concerns internally. We already have code that's listening for clicks, listening for key downs. We are already doing concerns around when the DOM's patching, we have areas locked, waiting for server acknowledgement. So we're already handling all these same concerns, and it fits nicely into the code we're already writing. But it ultimately started with, we have this click and escape key event that we have to go to the server, and we shouldn't have to go to the server. It should happen instantly on the client. And didn't mean to hit escape. So what we can do with the JS events is you can now, within the Heeks brackets, say, I'm going to JS dispatch a click to some selector, and it's going to click the live patch link, and we're done, right? The JS dispatch solves this problem for us, and we're not sending a JavaScript event from the server. We're just declaring that this is what should happen on the client when someone clicks or someone hits the escape key. And we also added a new Phoenix click away binding, which allows you to say, like, if this element loses click focus, then fire this event, just like a Phx click. So this solved that initial concern for us. We can dispatch DOM events based on Phx bindings. So problem solved, right? So pretty neat, but not revolutionary. But it gets more interesting because we have other utility classes. It's not just about dispatching DOM events. We can do other things like add or remove classes. And this isn't, you may see this and think like, well, you're just trying not to write JavaScript, but that is not the point here. The point is, if you're modifying the DOM with adding classes, removing classes, trying to do animations, we may patch content over top of you that undoes all of the operations you've done. So we have this mismatch where the server is sending DOM patches down the wire, and the server is not aware of you having added that class. So our JS commands are DOM patch aware, and they will stick across patches that the server is sending. So that's the critical path here, is you can declaratively say, I want to perform these utility operations, and it's going to play nice with any updates coming from the server. So if you toggle some content, you want to show a modal instantly on the client or hide it instantly without making a round trip to the server, you can do that now. And if an update comes through live view, it's not going to suddenly show the modal again. It's going to remain hidden. So you can do that with like add or remove class. We have show and hide. We have toggle, which is going to say, like, if I just want to toggle something in or out, like, I don't have to have logic to say, like, if it's hidden, show it. If it's showing, hide it. Toggle just internally knows how to toggle. And then I can even give it in and out classes. And this is just CSS, like a fade in or fade out that I have defined in my app, and it's going to apply that class. Yeah, I can dispatch DOM events like you saw. I can literally just do animations by doing a JS transition. So if I want to apply like a CSS highlight that like makes it blink or something, it's going to apply a CSS transition internally for a fixed amount of time and then remove that class. So you end up in all these cases where a lot of people often ask me, like, if something happens where like a post is updated, they want just to reflect to the user via CSS, like, hey, visually show that this post has changed instead of just updating it silently. So to do that was difficult before, but now you can literally just trigger a transition. And then we also have a extended push API, which we'll see in a moment, which solves like 12 problems in one feature. And I'll show you that in the demo I'm about to do. But instead of specifying just a string to be pushed, you can use a push function. And this is discoverable and supports a number of options that under the Phx options that we had before. So we'll see that in a moment. I think the best thing to do to show off JS commands is to demo them. So I can't give a talk without doing some amount of live coding. But if we fire up a modal here, yeah, this is working. We can see that modal that we were just looking at, and we have, that's in this file. We have this Phx click away, and we're just dispatching a click to a selector. Or if you hit escape, we're dispatching the click to a selector, and that is this ID here. And since all we need to do is dispatch the click, and that element is a live patch, if I click away from the modal, it's actually just going to click this close button internally, right? So if I click away, the modal disappears because all we did is on the client say, actually click the close button. So works nicely, not revolutionary, but the interesting thing is what else you can do. Because a lot of people have wanted to do transitions and animations for a long time in live view, and it's never been easily done, even with other UI libraries that can do animations, because if the server is patching the DOM during animation, your animation ends too early. So we necessarily needed some feature that allowed transitions to happen and for live view to be aware of it. So let's add some UX features here to transition the modal, both because it's a pleasant experience, but also it helps to hide latency. Like even Apple does this when you swipe back and forth on the app. Any animation you're showing is going to hide, 200 milliseconds of latency. And as far as the user is concerned, it was still instant. And in fact, some people are adding latency to their app because users are reporting, like when they close a modal, that it was too fast. Like it instantly disappears and stuff happens too quickly. So people paradoxically complain that stuff is too fast. So the idea is like animations and transitions are just good UX, but they also allow you to then mask some latency that's necessarily going to exist depending on what you're doing. So in our case, I've got some CSS classes that I've defined in the app, like fade in. So on the modal box itself, I want to fade in and also scale. And this is just a CSS class. So there's nothing special here. I just have CSS animations like fade and scale, fade in. And what I can do is on the modal box, just when I render it, I don't have to use any special JS commands. I can just say, when you render the modal container, fade it in, the backdrop fade in. When you render the modal container, scale it in. I hit refresh. If this video is coming through at the proper frame rate, you should be able to see the modal actually fade in nicely. So this is just standard CSS classes, no live view features. When you add something to the page, the CSS takes over. But where it gets interesting is if I want to say like, well, if this modal is closed, I also want to transition it. And here's where I can say like, well, I'm dispatching a click to this close button. So then we can handle clicks with Phx click, right? So this element is being clicked anytime you click away or hit escape. And then Phx click is JS command aware, all the Phoenix bindings are. So here's where I can actually hide the modal by doing like js.hide. I can send a hide to a selector, which is going to be the couple things. It's going to be the modal container. And I want to hide the modal container by transitioning it with a fade out. And here's where I can actually say transition. I give it a CSS class named fade out. And that's going to fade out the background. But then I also want to fade out the modal container itself, the modal box. So these JS commands compose. So I can pipe to another JS command. And this is going to scroll off the page. I'll extract it to a function in a moment. But here's where I want to hide the modal, and I also want to send a hide to the modal container itself, which I call modal content. And here's where I can also say transition, and here's where I can specify fade out scale. And now encoded in the DOM is how to handle when that thing is clicked. So if I click away now, you can see if the frame rate's proper, I don't know if it is, but it should be. You should see that when I click away, it's going to click this, and that's going to trigger the Phx click, which has these commands internally, which fades out different DOM elements. And it looks super nice, and it works as you would expect. But it goes even further than that, because we added a new binding called Phx Remove, which is, if the server removes an element from the DOM, I also want to be able to fade it out instead of it just like suddenly disappearing out from underneath me. So you can specify that with Phx Remove, and this is JS command aware, just like all the other Phx commands. And here's where I want to do the same thing. So the nice thing about this declarative syntax is it's just Elixir, right? It's just Elixir structure. So here I can extract this to a hide modal function on Phx click on the close, and also I'll call hide modal on Phx Remove. And then I just write a function that encapsulates what it means to hide a modal. And this can be composable, so I can say it accepts a JS struct, so other people can do what they want and then call hide modal. And here's where it will just call your JS commands. So we'll take whatever we got, pipe it to JS hide, and we hide the modal and the modal content. So now if I refresh, open this, click away, that works as expected. But then if I hit the back button, it's going to fade out, right? So the back button removes it because it patches over top of the whole page. But in this case, it's still faded out. It didn't get removed instantaneously because of the Phx Remove. So the JavaScript commands are, again, about declaratively saying what should happen instantly on the client, and they're DOM patch aware. So transitions work as you would expect. You can add classes and remove classes, and you can take this a lot further than I think most people think. So I can show you that with another little example I put together. This is the I have like a Twitter Bootstrap example. This is just as applicable to like Tailwind or any other CSS library that you want to support. But in this case, Twitter Bootstrap out of the box, if you want to use some of the like tabs or modals or toasts, requires a Bootstrap JS, which is internally doing all the client-side concerns. So here I've implemented Bootstrap JS, but just in JS commands in LiveView, so no JavaScript. Bootstrap-related JavaScript is running here, and I'm doing a counter here to show the DOM is updating. But now I can navigate between these tabs here, and the DOM is continuing to update behind the scenes, and it's not like unsetting my classes, right? If you were trying to use Bootstrap JS before and you clicked profile and the DOM update came down, it would undo the class, and you'd have to write a bunch of internal JavaScript details to reapply the class. That no longer is a problem for you. So here I have tabs. I've got Bootstrap modals, which fade in, and these modals are on the client already. So I'm fading in or showing and toggling that content instantly on. It's not going to the server to render the modal. Clicking away hides it. Clicking the close button closes it. And then the accordion, I can toggle an accordion content, and it's going to work as you would expect. And then the neat thing is the fact that the JS commands are composable means that I can do client-server operations where stuff instantly happens on the client and the server still can get in on the action. So one example is the toasts that are showing here. I'm simulating like events coming, but imagine that the server only wants to show 5 at a time because it doesn't want to overflow the scroll back for the client. So in this case, I'm showing these toasts, and then the server knows how many are on the page at the moment, and it's not going to send any more. It's going to buffer them. So if I click X on the client, what you would do previously is you could tell the server about it, but then the client is going to experience that latency on the toast disappearing before it disappears. But for us, we can use JS commands to say instantly close the toast on the client and then also tell the server about it. So if I start closing these, they instantly fade out, and then the server is going to start sending more. But it is happening without latency on the client because it literally happens the instant they click the toast on the client. And then also if I hit escape, it hides all the toasts by default, and then the server is going to start sending more. So we'll hop into the code to see how this works, but this is using just the stock JS utilities that we saw previously. And this is what I mean by people being able to write extensible UI libraries that they can share with the community, because you could wrap Bootstrap or Tailwind UI entirely. It could do all the rich client-side stuff that happens on the client, and you wouldn't have to have the user like start adding JavaScript to their app and then figure out how to write a Phx hook to reapply classes. Like, this is all solved internally for you with JS commands. So what that looks like on the UI live level is just utility functions like we saw, where we can say I've got, anytime I want to show a modal, I can write a show modal function. If I want to hide all the toasts, I can write a function to do that. And then when I'm rendering the notifications, these are just Bootstrap toast containers. But the neat thing is these functions take a node ID and they can target through the JS command specific node to close. So it's a very natural way to kind of handle these utilities, where I can say for every node toast that I render, anytime it's clicked on, I'm going to annotate this attribute that it should hide the toast with a specific ID. So if we check out that toast function, again, it's just what we have seen previously with the utilities, where I can say, well, we're Bootstrap. The way Bootstrap shows and toggles most content is with like a show class or an active class. So it's easy for us to replicate that in LiveView. We just say remove the class show from the toast with that ID. But then at the same time, we're going to push an event to the server like dismiss notification. And that's how the server knows, like, okay, the client has dismissed this. I can start sending more events. So it composes really nicely with this entire hide toast operation is already on the client, waiting to push the event to the server and instantly remove or hide it on the client. And then all the other utility functions are very basic. Showing the modal is just a matter of toggling content. Showing the tabs when I do like home and profile here is just internally Bootstrap JS was just adding active or removing an active class. So you give it a tag name or a tab name, and we just do that. And what that looks like in the markup is the home button just has a PHX click. We just call show tab home. And if you're familiar with Bootstrap, what Bootstrap would do is they would also annotate the markup, and it would be like data BS target equals home. So it's like, it's no more or less code that you would have to annotate. In our case, it's fully, Elixir backed. The functions are discoverable and documentable and reusable. So definitely, I think people can take this further than what they initially think. And you can essentially write an entire UI library and release it to the community without them saying, okay, also copy this JS to your project. So I'm super excited to see what people do with this. Again, it's in a PR. It will be in master probably by the end of the day today. So definitely check this out if you're interested in doing things on the client and releasing UI libraries. So I mentioned like this inflection point where we're able to, we've got these building blocks and we're able to start tackling, I think, more ambitious and quality of life features. And we're not stopping with slots or function components or JS commands. What we want to do next is declarative assigns. So this is something that Marlis has done in Surface, which is really fantastic. And it's basically a way for you to specify for a function component what assigns you accept and maybe their data type. And that way, if you try to render a modal and instead of passing the title, you pass the heading slot or the heading assign, if that's not supported, you don't want to find out at runtime via assign not available. You want to find out at compile time. So we have an idea of how this would work internally. So it's next up on our roadmap to give you those quality of life developer experience of things should blow up when they're obviously wrong, and we should be able to detect that. And then another big thing that's been on my list is intelligent collections. So you can make arbitrarily length collections work in LiveView efficiently today, but you have to make sure you render components per item. You have to use like Phx update, append, or prepend. So it gets tricky to do the optimal thing. And what folks often do is they'll just write a for comprehension with a list of items, and then they'll be surprised when they update one thing in the list that the whole list gets resent to the client. So the idea is collections should be intelligent to know, like, if I only change one item in the list, and that only that item is going to be sent over the wire. So we have to do some thinking internally on what this API would look like to let LiveView know that you're just updating one element in a collection. But this is definitely on our list to tackle. Another big thing, if you've been writing moderately complex LiveView applications, is you'll often run into a mismatch between LiveView and component messaging, where components can be messaged with send update and LiveViews can be messaged with just process send. And this is a problem because if you want to have a component that says, hey, I messaged my parent when I processed some event, you then have to know what your parent is. You have to know, is it a LiveView? Because I need to send it a message. If it's another component that rendered me, I need to send it a send update. So there's this mismatch where at Dockyard, we've solved it with our own like wrapping functions that do a notify based on the type of the parent, but it's definitely a mismatch that needs a unifying API, and this is something we're exploring on the Phx team. And then with live redirect in place, with live session, we want to be able to stash transport data on like the WebSocket connection. And this would allow us to say, only fetch the current user for the lifetime of the user visit, right? Like when the user loads the web page, there's certain things that can be loaded that are always going to have to be there. We should be able to just put that in like a registry on the transport and have that be available to all live views instead of having to refetch when you navigate. So again, live navigation is extremely efficient, and we want to make it even more efficient by allowing the transport, which is already long running and long lived, to hold data that you can access. And then we're also reimagining the form API. So we've done this a couple of times. I mean, we just shipped a form function component in the latest live view with the .form that you've seen. But if you've noticed, like all the form input builders like text input and label, those are all still regular EEX functions out of Phx HTML. So we want to reimagine what this form component would look like if we started from clean slate and just use function components. We could, in this case, we'd be able to send a lot less data than we currently send. And I want to explore also sending less data from the client long term, but keep an eye on this space because I think it's going to be better to write and then also much more efficient on the wire. And the interesting thing that we've seen with LiveView, that LiveView is, I'm going to say 2 years, but I actually think it's well older than 2 years now, so someone can fact check me. But what we've seen is this idea has caught on like wildfire, and we've seen it across basically the entire programming language ecosystem with people directly inspired by what we're doing. So Java has Medusa, which I just saw, which is literally claims to be inspired by LiveView. PHP has Livewire, which Caleb, the author of Livewire, is also the author of Alpine.js. So it's no surprise that Alpine.js works really well with LiveView applications because Caleb is in this similar problem space. So PHP has Livewire. Ruby has Stimulus Reflex, and then Rails released Hotwire. Python has Django Reactor, which is literally claims to be Phoenix LiveView for Django. Go has a library called Live, which claims to be a reimplementation of LiveView for Go. Haskell has a library called Replica. And then like we've come full circle where like at the beginning, I took React and I put it on the server with LiveView, and then like the front-end community, you know, this may or may not be the case, but it seems like this idea has caught on like wildfire. And then the front-end community is like, oh shoot, we need to take React and put it on the server. So it's like really interesting that we've come full circle and now React can also be on the server. But I think the nuance is missing here is the fact that we do things much differently than most of the platforms we see here. And I forgot to mention on this list, C# has a Blazor framework called server-side Blazor, which is doing essentially something very similar to Phoenix LiveView. And Blazor was started nearly at the same time as LiveView. I'd have to go back and look. I wasn't aware of it, but I feel like the project started the same month. So I should have put C# on this list. But apart from the Go and Haskell or C# implementations, there's a big difference on the approaches that other platforms can take. And I think what we've seen is people have tried to brand this new space that seems to be catching on everywhere. And I've seen it named a few different things. One is like smart server applications. Another one is HTML over WebSockets. And I've also seen transitional JavaScript applications. I don't like any of those names. And I feel like if we helped birth this genre of applications, I feel like we at least should have some part in what we refer to these kinds of applications. So I think that part of naming, like trying to figure out the name of this genre, it's important to highlight the things that we do differently than what other people are trying to do in an effort to replicate us. So I think the biggest takeaway is we have live running processes on the server that represent the UI for the user. So our applications are actually up and running and alive, and they can send events to the client at any time. It's not about just an application when you click a button updates the UI. It's you have an application, when you click a button, it updates the UI, but it may update the UI across the world for everyone's browser. Or at any time on the server could say, I've consumed some new data, I'm going to update everyone's UI. I have a real running UI for the user on the server that is sending those updates over the network. It's actually up and running on live. And most of these platforms have no concurrency model to do that kind of thing. So the Go library, the Haskell library can effectively take our approach where we have a real running concurrency representing a UI, but most other things can only say we can handle the user interaction part, but we actually can't handle these out-of-band updates in any reasonable way. So what I'm internally referring to these applications before they get named something or before we get locked in with something like a smart server is, what we're doing is special and it's not easily done on all platforms. So I think taking some inspiration from our own name, I think what I'm going to propose is calling the space live applications. And the big thing here is we have up and running live processes on the server handling the UI. And Go can do this. The Java Medusa may be able to do this, although they have to use threads and try to simulate this. So very few platforms can do it, but it can be done. And this is strictly different from like HTML over WebSockets, where you can push out and broadcast updates, but if you're just pushing out HTML fragments, all you can do on the server is say like start up a background task out of some database store, render some HTML fragments, and then go poke everyone's browser. For us, it's not the case. We actually have up and running UI for that, all those browser windows. We can send a message to that UI, and it can handle it however it wants and render its own template diff. So that's a much different model than these, I'd say, otherwise stateless applications, is we're stateful. So we handle the updates on the server because we have processes up and running. We can actually be alive and send live updates. And this is different from single page apps, where a single page app isn't live in the sense that I can write some JavaScript that does some stuff on a page, but until I wire up a server, how do I get real-time information to that client? I can use stateless HTTP, I can establish a WebSocket connection, but I have to go solve that entire problem space to try to make even a single page app live. But for us, this is just built into the platform. So I'm proposing, if this ecosystem around LiveView must be named, I think we should refer to them as live apps. And I think they're the subset of LiveView live applications that can actually represent a UI on the server as this up and running piece of concurrency. So let me know what you think about that. But I think if it has to be named, we definitely don't want to call it something that doesn't well represent what LiveView is doing. And I think this kind of gets to the point where we started this idea a few years ago, and it's caught on because I think people are seeing kind of the pendulum swing back from the front end is necessarily complex in a lot of ways, but only for certain problems. So I think what people have done historically is picked up a front end heavy application framework because they want kind of this rich real-time UI, and then they adopt all the complexity, but that's no longer something that they have to choose. And if they're not building Google Maps or Google Docs, it's often like not even something that they have to think about, but they pick them up anyway because that's all they had access to. So I think I want to kind of have people think about that, LiveView, it changes, this is a blog post I wrote, but it changes the frontier of what you can reasonably accomplish in an application. Because you may look at LiveView and say like, well, I can do this on the client side, right? Like you're just trying to avoid writing JavaScript. And it's not necessarily about that. It's what can I actually reasonably accomplish, right? If I want, the client comes to me or my boss comes to me or the product person says, if someone adds something to their cart and that item is now close to being out of stock, how do I update that? I want to show them, hey, this item's almost out of stock, please check out. Trying to solve that if you've written a single page app is like, well, do we have WebSockets? And the answer is probably no. It's like, well, we need to start a WebSocket connection. So you pull in a WebSocket library, you go talk to your ops team because they're probably not provisioning for WebSocket connections. And then you're like, well, how do I broadcast? And you're like, well, I'm going to have to like bring in some kind of message queue or Redis into my app, run some jobs in the background. Like you end up in this labyrinth of complexity for what for us in Elixir is going to be like, oh, yeah, we can do that. We would just do a pub sub broadcast when the item goes out of stock. And that's just going to arrive in a live view and the template's going to update. Like there's no complexity tax to even thinking about making features real time. So whatever makes sense to be real time or dynamic just is. And I think that's the critical takeaway for LiveView is the fact that we can do that without further thinking. It's not that like, well, I got to weigh the pros and cons of establishing a WebSocket. I've got to figure out like, I got to put it into Redis now. So I got to talk to the ops people to start deploying Redis. Like none of that is even in the equation. You just deliver features. So I think this is really why this idea is catching on, because it's not just about simplifying the programming model. It's simplifying the entire aspect of delivering features, because you remove layers of complexity. And even for what single page apps can claim to do, as far as being like able to run things instantly on the client, they have nothing to say out of the box on how do you propagate updates to everyone connected to the browser. How do you at any time push an event to the server and have the UI update? That's something that you have to go solve or pick up other frameworks or integrate. For us, that's just built in. So I'm super excited to see kind of the next phase of LiveView as like this idea has caught on, that we're able to start delivering the features around slots, JS commands, and having reusable components be shared in the community. Because I think we're going to really start being able to show demos and applications where you can just say like, here's an off-the-shelf app that I'm able to bootstrap insanely fast that's going to compete head-on with any single page app, be able to run things instantly on the client that should be instant. And I think that's going to really help us in for people trying to say like, oh, you're just trying to write this little toy thing. It's like, no, we can actually be better than a lot of single page applications, and the features that we've worked on, I think over the last 6 months, are going to get us over the finish line to allow people to actually do that. So that's all I have. Definitely know what you think. Check out Flyio. Super excited to be here. And Mark, my coworker, Mark Erickson, works at Fly as a Elixir developer advocate. He's from the Thinking Elixir podcast. He's giving an awesome talk just after this about doing distributed Elixir and Phoenix and LiveView applications on Fly geographically. So definitely check that out. He and I have been tinkering on some really interesting libraries. So that's all I have. I don't know if we can do questions remotely, but I'll definitely be around on the conference application if people want to reach out to me, or Slack.